Now we're going to look at how to add vectors in this video on addition of vectors. When you add two or more vectors, you are finding a single vector called the resultant. The resultant vector is often represented by the symbol R as a capital letter with, of course, the arrow on the top. The first method is called tip to tail. Here is an example. You are given two vectors, vector A and vector B. Vector A and vector B. You want to find the resultant when you add these two vectors together. Think of vector A plus vector B as A followed by B. This could be illustrated as vector A, and at the tip of vector A, draw vector B. So the tip of the first vector, the tail of the second vector. Now, find the sum by drawing and measuring from the tail of A to the tip of B. Label this resultant vector, vector A plus vector B. The new vector is the resultant vector, vector A plus vector B. We could use the parallelogram method of adding vectors. You are given two vectors, A and B. Vector A, vector B. Position B so that the tail of B touches the tail of A. Now, complete the diagram by drawing a parallelogram. Draw a line parallel and equal to A from the tip of B, and draw a line parallel and equal to B from the tip of A. Label the last line you drew vector V, and we know that vector B and vector V, B and V, are equivalent vectors. Now, complete this shape by drawing a diagonal from the tails of vector A and vector B to the tips of vector V and the parallelogram vector A. Using the tip to tail method, this diagonal can represent vector A and plus vector V, which would also represent vector A plus vector B. Note, when using a diagram, CAV, with vector A and vector B, and we have the inside angle, theta, and we then draw the parallelogram, we still have vector theta, but the measure of angle B is equal to 180 degrees minus theta. That's an important property that we will use when we're solving problems. We know that angle CAB is theta, and vector ABD is 180 minus theta, and they're supplementary, meaning the sum of those two angles is equal to 180 degrees. Now, let's look at an example. Namisha is walking to the library, which is 3 kilometers east and 2 kilometers north of her current position. Determine the magnitude of the resultant displacement to the nearest kilometer. Determine the direction of the resultant displacement as a quadrant bearing. Let's start using the tip-to-tail method. Draw a diagram to represent the situation. Make sure you draw the diagram to scale. We have the direction 3 kilometers east. She turns and goes 2 kilometers north, and now we have the resultant vector. To solve this, we are going to know that it's a right angle triangle because we went from east to north. So we have the two sides. We can calculate vector r using the Pythagorean theorem. Hypotenuse squared is equal to side 1 squared plus side 2 squared. To do that, we're going to substitute the given values into the equation, and we're going to solve. So, 3 squared, 9, 2 squared, 4, and take the square root of that, so our resultant would be approximately 3.6. That would be our magnitude, and our unit of measure is kilometers. Now, we want to calculate the direction of the resultant displacement as shown as theta in the diagram. Tan, we know, is equal to opposite divided by adjacent. Opposite is 2, adjacent is 3, which gives us the measure of 33.7 degrees. So theta is approximately 33.7 degrees. We now want to use the value we found for theta to find the resultant displacement in quadrant bearing directions, which would be this angle coming from north to east direction. So to do that, we know that theta is 33.7 degrees. The quadrant bearing is the angle between the north direction and the resultant vector. So what we would do now, we want to calculate the direction of the resultant displacement as shown in the diagram. We know that theta is 33.7 degrees. To find the resultant angle measure, we want to subtract the value we calculated, 33.7, from 90. So this would give us the bearing angle of 90 degrees minus 33.7 degrees, which would be 56.3 degrees. The direction of the resultant displacement is north 56.3 degrees east. Now let's look at a second example. Example number 2. Vector u has a magnitude of 30 newtons, and vector v has a magnitude of 40 newtons. When placed tail to tail, the angle between u and v is 50 degrees. Determine the magnitude of the resultant vector u plus v. Determine the direction of the resultant vector u plus v. We're going to use the parallelogram method as we are given the values tail to tail. Draw a diagram to represent the situation. It's always better to draw the diagram to scale. This will help you to visualize what's going on in the question. So we're going to draw the first vector, 30 newtons. We're going to rotate 50 degrees, and we're going to draw the second vector at 40 newtons. Vector u and vector v. Now once that is done, we're going to draw the two sides to complete the parallelogram. So we're going to draw 30 degree Newton v and 40 degree n for u. From there, we're going to draw the diagonal. To make it easy for us, we're going to give the vertices labels A, B, C, and D. We know that angle ABC is 50 degrees. We know that angle ABC plus angle BCD is 180 degrees. So we would know that angle BCD plus 50 degrees is 180 degrees. So angle BCD is 130 degrees. Now, we can use the cosine law because we have the length 30 newtons and we have the length 40 newtons and the contained angle of 130 degrees. Just to refresh, in this situation, the resultant vector is BD squared with B side BC squared plus side CD squared minus 2 times vector BC times vector CD times the cos of 130 degrees. So if we substitute in the values, we would get vector BD at being 63.6. From there, we need to determine the angle DBC. To do this, we can use the sine law. So sine angle DBC over CD is equal to sine angle BCD over BD. We're going to substitute in the values. CD is 40 newtons. Angle DBC is what we're trying to find. Angle side BD is 63.6 newtons. And angle BCD is 130 degrees. Substitute these values into the equation. So sine angle DBC divided by 40 is sine 130 degrees divided by 63.6. Cross multiply, so sine of angle DBC is 40 times sine of 130 degrees divided by 63.6, and we get the measure of 28.8. So our conclusion, the magnitude of the resultant vector, 63.6 newtons. The direction of the vector is 28.8 counterclockwise from the horizontal. And it's your turn.